Okay, we have a very short enrichment video for Chapter 1, Lesson 6. This video is optional, but it does show you a different way to solve these problems, and I do think it's beneficial for us to see this. It kind of sets us up nicely for something in a later lesson in our chapter anyways. So if you are in your notes, I am looking at, I think it's page 9. Yes, it is page 9 in your notes. So I have these same notes kind of typed up for us here. It says we can solve proportion problems in a different way. We can use an equation to solve them. So there are 3 steps to do that. The first step is to find the rate in the problem and then write it and change it to a unit rate. After we have our unit rate, we can do something called defining our variables. And we're going to use smart variables here, variables that help us represent things within the problem. And we're going to place them into the unit rate. Then we're going to write our equation. And our equation is written with our top variable first. That's equal to the numerator times the bottom variable. Okay, so bear with me. I will show you how this looks with our cookies problem from the last video. Our last note for this enrichment video is in the equation. Once we have our equation written, that numerator, the number that sits in front of the variable, will be called the constant of proportionality. Okay, so let's take a look and see how this works. So here's our same problem from the last video. It's all about Andrea. We're familiar with this video. She wants to bake 8 cookies for every 6 people attending a party. So the rate here is 8 cookies per 6 people. So there's our rate. If we want to change it to a unit rate, I am going to actually change it to a unit rate in a special way so that we have a fraction numerator and a 1 in the denominator. I don't want a decimal here because I know my decimal will be a repeater. Okay, so when I divide by 6 and divide by 6 to change this to a unit rate, 8 divided by 6 gets me 8/6. And if I simplify that, I get 4/3. I could change that to 1 1/3, but I'm going to leave it as an improper fraction. And I'll say that my unit rate is 4/3 of a cookie for every person, for every one person that attends the party. I know that looks a little bit weird. Obviously, they're not going to be breaking cookies up into thirds, but that's kind of the average that Andrea is making, 4/3 of a cookie for every one person. So now, step 2 says to define the variables. Well, when we defined our variables, we kind of did that already without thinking about it, but see how I have the letter C up here, the letter C right here, and the letter P here. C represents cookies, P represents people. Those are going to be our variables. C for cookie, P for people. And I already have them within my unit rate. Now to write my equation, remember what we said in our notes right here. This is the tricky part. There's a formula for this. Our top variable is equal to the numerator times the bottom variable. So our top variable is C. So the number of cookies she needs is equal to 4/3. Or if I had changed that to 1 1/3, that would have been okay too. 4/3 times the bottom variable, so 4/3 times P. So there is my equation. The number of cookies that she needs is equal to 4/3 times the number of people attending the party. Now we can use that equation and we can solve our problem with it. Trying to get my page a little longer here. I may not be able to do that today. So we can use that equation and we can solve it to determine how many cookies we need. And all we do is we say, okay, well, what else are they giving us in the problem? They're telling us the number of people that are attending the party, 27. So all we have to do is take that 27 and substitute it in for P. So we get C equals 4/3 times 27. Remember to put your 27 over 1 so we can multiply our fractions. We can simplify here. Let me change colors. We can divide a 3. 3 divided by 3 is 1. 27 divided by 3 is 9. And then we can do our multiplication. 4 times 9 is 36. 1 times 1 is 1. So that tells us that she would need to make 36 cookies. So just a different way for us to look at this problem. We solved it using what's called the constant of proportionality. And that would be this number 4/3 right here. That means that's our number that represents the proportion, 4/3. Or like I said, we could have taken the time to change it to 1 1/3 as well. It really wouldn't have mattered. Okay, so that's just our quick video on how to solve these problems in a different way. If you want to try it out, go for it. If not, we will see more about the constant of proportionality in a later video.